Hello.
Hello.
Okay, can you hear me?
Yeah, I hear you.
Okay,
Good.
so how are you?
Oh, thanks. I tried to do something in GIA, and
Okay.
it's good. I can. Thank you.
Okay. So basically, as a beginners, it's very difficult to learn, but I will try to teach you as a beginners who don't have anything. I hope you can easily overcome all of the problem, and you can easily learn this Google Earth Engine platform, and you can easily develop your own algorithm, your own analysis. You can easily do. Okay.
Yeah, thank you.
Okay, so let's go to today's class. So basically, today is our fourth number of class. Okay, and today I will try to discuss about the some more advanced topic on Google Earth Engine platform, such as how you can easily remove the cloud from your satellite images, how you can easily work with the land surface temperature monitoring, and how you can easily make the land surface temperature time series chart. Okay, so let's go. We try
Okay.
to jump our class. So I simply share my screen. Okay, just I simply start the recording because I also provide you the recorded video class. Okay, so now can you see my screen? Yeah.
Yes.
Okay. 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 So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. And I am course coordinator of this 7 days online training program. And so basically, this is our full course content. We try to complete all of the topics within the 7 days. And today is our fourth number of class.
Yes.
And today's topic is that first of all, I try to discuss about the topic how you can easily remove the cloud from your satellite images. So mainly you can see when you want to work with the cloudy image in rainy season or wet season, we can find out the lot of cloud in the sky. Okay, so when you want to work with the rainy season or wet season images, here you can find out the lot of cloud. Okay, and cloud is very difficult when you want to make the land use land cover classification. Okay, so when you want to work with the cloudy image, then you can find out the some cloud and haze from your satellite images. Okay, and this cloud is very difficult when you want to make the land use land cover classification map. It's cloud when you want to make the land use land cover classification map using the cloudy image, you did not get the better result. Okay, your result, you can get the some problem in your result. Okay, so that's why today I also try to show you this part how you can easily remove the cloud from your satellite images, and you can get the totally clear satellite images in using the Google Earth
Okay.
Engine platform.
Okay. Great.
Then we also try to discuss about the visualization of the DEM data. So mainly digital elevation model data, how it will be worked. We also try to discuss about this. And we also try to discuss about the land surface temperature monitoring. So mainly in this time, I try to discuss about that how you can easily make the land surface temperature map using the MODI satellite imagery and then make the time series chart. Okay. And then we also try to discuss about that how you can easily calculate the average, maximum, minimum, NDVI for any specific region. Okay. So let's go. First of all, how we can easily remove the cloud from the satellite images. So here you can see this is the one types of satellite images. Mainly in the satellite images, here you can find out some cloud. You can see this is the white
Yeah.
pixel value I can find out. So this is the cloud. But when I want to remove the cloud using the cloud max band function, then I can get the very clear satellite images. You can see these satellite images, there is the now cloud. Okay, but this
Oh.
is same time period satellite images, same image. When I am applying here the cloud max band function, then this cloud is automatically removed. Okay, so let's go our practical. I also try to show practical how you can easily do this. So I simply open my code editor.
And Can I have you some questions?
Yeah,
Ask
please, you
you
can
some
ask me.
questions.
Yeah, please.
All informational in satellite images under cloud is safe, yeah, or no?
No, it's not safe.
Not
So
safe.
yeah, so we
Ah,
need to
okay.
we need to suppose when you want to remove the sentinel satellite images, then we need to also apply the another process. When you want to apply the Landsat satellite image, you need to also apply the another process.
Ah,
Okay.
okay. Mhm.
So I also try to show all of the process. Just a minute. It's not loaded. Okay, just I simply open this my code editor. Okay, some networking issue. I think it takes some time. Okay, so now it's open. Okay, so now you can see I simply work with suppose Sentinel 2 satellite images. So just I simply search at the Sentinel 2, and here I can find out the satellite images. You can see
Mhm.
I want to work with the
Yes.
satellite images and then try to remove the cloud from the satellite images. Okay, okay. So first of all, I simply import this image collection in my code editor. So now it imported. Okay. Suppose this satellite images, here you can see image collection. It's a default variable name. If you want, you can change it. No problem. I simply change it and put the name Sentinel 2. Okay. I simply put this name Sentinel 2. And then suppose in this time, I need the satellite images for my region, region of Dhaka city. So just I simply import my shapefile. So here I already imported my shapefile asset tab. I simply import the shapefile of Dhaka city. I simply import this, okay, and put this name. Suppose it's my ROI, okay. In this time, I filtered this image collection according to my region of interest, Dhaka city shapefile. Okay, I simply take a variable name. Suppose I put the variable name is the image. Suppose image. You can use any variable name. I use the image. I simply
Okay.
call my this variable name Sentinel2. Okay, because all of the Sentinel2 image collection is stored in this variable Sentinel2. I simply paste in here, and then I simply use a function filter bounds function. Okay, in this time I just intersect all of the image collection with my
Mhm.
shapefile, and my shapefile is stored in the variable name is that ROI. I simply write here the ROI, my shapefile
Mhm.
variable name, and then I simply put the time period. Suppose I simply use the filter date, and then I simply put here the time period. Suppose year of 2021. Suppose 1st January from year of 2021. Suppose December 31. So this is my time period. I simply put this, and in this time I also need to filter this image properties or image metadata. Okay, in this time I simply put here the properties name, image properties name. So I simply click on here. Here I can get, you can see the image properties name is that. I just simply put on the, you can see image properties. So I want to work with the cloud pixel per sentence. So I simply copy this cloud pixel per sentence and then simply paste in the name. So I simply paste in here. And then I simply select the operator. Suppose less than. I simply put here the less than, suppose 1. Okay. So now you can see, I just simply check how many images I want to get for my region, which is the less than 1% cloud pixel per sentence, and which the stay in this time period. I want to check it. I simply use here the image and use here the size function. So now it showing me the result. How many images are available? 44 images is available. which are less than 1% cloud cover and which are available between the year of 2021. So in this time, I just simply make the median composite from creating all of the 44 images, okay, and display the result. So just I simply use that the map dot add layer function, and then call this image, okay, and click to the run. So now you can see one layer is added in here, but I did not see the image of Dhaka city, okay.
Yes.
So for this, in this time, I need to focus the center of this Dhaka city shapefile, okay. For this, I just simply use the map dot center object, and then my object name is that Dhaka city shapefile variable name. Dhaka city shapefile variable name is that ROI, okay. I put here the zoom level suppose 10 and click to the run. So now you can see it showing me the result of the Dhaka city, and you can see I can get the result as a tiles. It's not clipping.
Yes.
It's not clipping with my shapefile. In this time, I just simply use here the clip function, clip with my boundary, and my boundary name is that ROI, and click to the run. So now you can say I can get the result only for my boundary area. Okay, so this is my boundary area. So I can get the result only for boundary area look like this. Okay, so in this time I want to add the visualization. So different types of band visualization I can easily add. So for this, I simply go to this in here, you can see, and click on here. Here I use here the different types of band combination. You can see band 4, band 3, band 2. It's called the true color composite. Red, green, and blue band or RGB color. I simply use stress 98%. And then I simply apply. So now you can see I can get the image look like this. Okay, I get this image look like this. But in this time you can see this image is not any cloud. Okay, I did not find out any cloud in this image because you can see I use that the cloud pixel percentage less than 1%. Okay, so that's why it remove all of the cloud. But in this time I need the cloud because I need to remove the cloud. So just I simply increase the value, suppose 90%. And then click to the run again. In this time, I can get some cloud in my satellite images. Okay, so now I simply add the visualization again. I simply click on here. Just a minute. I simply take the message then. Okay. So now I can say simply added the band before, band 3 and band 2. And it's just 98% and apply. In this time, I can get some cloudy image. Okay, so there are no cloud. Okay, just I simply I use the year. Suppose I 16. Use there the another time period, then find out the some cloud. Okay, because I need to remove the cloud.
Okay.
Then I click run again. Then I simply P4, P3, and P2, 98%. Okay, so now I can find out some cloud, you can see.
Yes.
In this time, this cloud I need to remove using the cloud marks ban function. Okay, so basically, suppose in this time I take the image for the whole year, but if you want, you can also put here only for the rainy season. Suppose I put the rainy season time period, it will be start from the suppose 06 from 010. This is a rainy season time period in Bangladesh. So I simply put this time period, and then I can also get the more cloud in these satellite images. And I also simply add here the visualization. You can see P4, P3, P2, state 98%, and apply.
Oh, yeah.
So now I can see there is a
A,
lot of
a
cloud
lot
we
of
can find
cloud.
out. Yeah. Okay.
And we can remove, is this all cloud?
Yeah, we can easily remove all of the cloud. And in this time, okay, there is a lot of cloud we can find out. You can see in the rainy season. Okay. So we need to remove all of the cloud and then try to get the. Okay, so let's go. We can try to remove. So if you want to increasing the value, suppose I put here the 1 and then try to again, because this is the cloudy image, we can get the lot of cloud. Now I want to check in cloudy image, cloudy time period, how much image is available for the less than 1% cloud cover. Then I check in this time, then 4, then 3, then 2, and 8% apply. So now you can see, I can, when I want to apply the less than 1%, then I can also find out some cloud in the
Yes.
rainy season image. Okay. So in this
And
time, I just,
shadow. Yeah,
yeah,
and
also you
shadow
can,
of
yeah,
cloud.
yeah. In this time, we just remove this type of cloud from here, such as this cloud you can see, and also you can get the cloud shadow. Okay. So in this is a shadow of the cloud. Okay. So in this time, we just remove the cloud and then try to make this clear satellite images in this time period. Okay. So let's
Okay.
go. In this time, I simply import this visualization. It will be imported. You can see. I simply copy and paste after the object name. This is my object image. I paste in here. So now it will be set with my code. In this time, I just try to remove the cloud from the satellite images. Okay, and also cloud shadow. How I can do this? So basically, in this time, we are need to work with the cloud marks band function. So here you can see in this image information sheet information, you can see the band. You can see they also provide a band. This band name is the cloud marks. Okay, and
Yeah.
this band name is the QS60. And cloud marks, this is the band name, and this resolution is the 60 meter. And this cloud marks QS60 has a some bit. You can see
Yeah.
bit 0 to 9 it unused. It's not need. But bit 10 it has the cloud, and also bit 11 it has also slash cloud. Okay, this bit 10 and bit 11 also has two signal, 0 and 1. 0 means there is the no cloud, and 1 means cloud present. Okay, also you can
Yeah.
see bit 11 0, there is the no cloud, and 1 it means that cloud present. So in this time I use here the cloud marks bit function band, and then try to remove the cloud and cloud shadow from these satellite images and get the clear satellite images. Okay, so let's go. In this time I use here the function. I simply use here the function and then select this band QS60 band. I simply select. Okay, and then I select the bit 10 and bit 11. Then I also need to select bit 10 equal to 0 and also bit 11 equal to 0. It means that there is the no cloud, there is the no slash cloud I identify. Okay, so let's go
Okay.
how you can do this. So I simply write this function. First of all, I take a variable name. Suppose cloud bit max. You can use any variable name. I simply use that the function keyword and put this variable keyword, suppose image. Okay, and use that the curly bracket. In this curly bracket, first of all, I take a variable suppose QA, and then I simply call this element name image and select this band name QA60. Okay, in this time I take the another, suppose I put here this cloud bit marks, take the another variable name cloud bits marks, and then I simply use here the one less than cloud. You can see there are the 2 bit. I simply select the 1 bit. You can see I simply select the bit 10. Okay,
Yeah. Yes.
I simply put here the bit 10 and also take the another variable, suppose cirrus bit max, and use here the one less than bit 11. Okay, in this time I need to use here the cloud bitmax equal to 0 and also cirrus bitmax equal to 0. So for this I simply take a variable, suppose max, and then I simply call this QA. Then I simply use here the function. If this function is the bitwise and then call this cloud bitmax and paste here and set equal to 0. Okay, the same things also use here the AND function, and also call the QA. This variable I simply call and I set here the QA bitwise and set this Syrah bitmax equal to EQ equal to 0.
Yeah.
Okay, in this time you can see I simply identify bit 10 equal to 0 and bit 11 equal to 0, and bit
Oh,
10 and bit
okay.
11 stored this variable cloud bitmax and Syrah's bitmax. Okay, okay, so in this time when I want, just I simply do this thing. You can see I also again explain. So from this band, first of all I simply select the QA60 band. Okay, this QA60 band select and then select the bit 10 and bit 11. I simply select the bit 10 equal to 0 and also
Yeah.
bit 11 equal to 0. Okay, so
Okay.
this I think using the function in here. I simply select the band QA60, I select the band 10, band 11, bit 11, I simply select. Then I select the cloud bitmax equal to 0 and also cirrus bitmax equal to 0. So it's identify the clear condition of these satellite images. There is a no cloud, there is a no cirrus cloud, it's identified. In this time, I simply use the return is image and use the update max function. Update max with this, I simply call this variable name and paste here. So now this image is update. This is my function. Okay, so mainly this is the function for removing the cloud from the satellite images. In
Okay.
this time, when I want to add this function with my image collection, then it will be remove the cloud. Okay, so for this I simply copy the same code from here and then I simply paste this code in here. Okay, and I put this name, suppose image. Take the another, suppose image cloud free. In this time, I simply copy this variable name, simply copy from here and paste in here. I simply paste in here. I simply use the map function and use paste this variable name, my function variable name. So now this function which I created in here, it will be add with my image collection.
Oh,
Okay.
okay. I see.
In this time, I simply show this result. I simply use the map dot add layer and then simply copy this very object name and paste here and click to the run. So now we can get the another layer. In this time we can get the, okay, so what is the problem? Cloud bitmax equal to 0. It's not bitwise and Okay, check again. I simply select the bit 10 and bit 11. Then QA, I simply call this QA and use at the bitwise and, okay, and then use at the cloud bit max equal to 0, and also select this another. Mhm. Just I write the function again. So just I simply call the QA and I set here the bitwise and this bitwise and I simply call this and paste here and use that the equal to 0, and also select the QA and use that the bitwise and call this slash bitmax equal to. Okay, from cloud bitmax is not equal to 0. Okay, just when I simply open my previous code and try to solve the problem.
Okay.
Okay. Okay, okay. So I need to write the function bitwise and then cloud bitmax equal to 0 and okay, okay. That's basically copy the same. just in this time QA, this is my band name. I simply call this cloud bitmarks this variable name in here, and also slash bitmarks. Okay, then QA bitwise and equal to 0. Okay, so then we can check. Okay. Okay, then I simply copy this and paste in here and click to the run. So now I can get the result. Another ladder also added in here. Okay, in this time we also need to add the visualization in this layer and then try to find out if the cloud is available or not. Okay, so I simply add the visualization. Use the band 4 and 3 and 2 and also 98%. Apply. Okay, so cloud is not removed. Cloud bitmaps will call this and then okay, 98%. It's only removing the shadow. Okay, okay. So I also need to add here this return image. Okay, divided with use here the divide. Suppose we can check. I simply added the visualization for 3 and 2 and 8%. Okay, so it's also not working. I try to run the question. I think some networking issue.
And we can remove all cloud and all shadow in images.
Yeah.
Mm.
Okay, in this time there is the no cloud you can see. Okay, so in this time I just simply remove the cloud marks function and try to show the image again. So I simply commenting this line. Now it will be not work. Then click the run. In this time you can say I can get the some cloud and also I can get the some haze in this satellite image. You can see. And when you can see this is a cloud pixel, we can get the some
Yes.
cloud pixel. Also we can get some haze in this satellite images. But when I want to create this function, this is my function. So I simply select this QS60, this band, and then select the bit 10 and bit 11. I set equal to 0 for the bit 10, also set the bit equal to 0 for the slash bit marks. Then I simply update this marks. And when I want to add this function with my image collection, I just simply use here the map function. and then try to simply copy this and use here and click to the run. In this time, when you can run this, you can see all of the cloud is the removed, and we
Yeah.
can get the very clear satellite images. You can see. Okay, so this is the process when you want to work with this. In this time, you can say I can get here the less than 90% cloud image. Okay, not less one or other thing. So in this time, it removing all of the cloud from your satellite images. We can easily get the clear satellite images. So now we can easily use these satellite images for making this any types of remote sensing analysis such as NDVI, NDWI. Okay, so I already created the NDVI map in here, or as well as also I created the NDVI map. So normalized difference vegetation index and normalized difference build up index. So we created two types of index in here using this images, cloud
Something
free
wrong with
images.
internet connection?
Yeah. Okay.
Hey,
So this is the
hello.
process. Yeah, please. Can you hear me?
Something wrong with internet connection, maybe?
Yeah. So something wrong in internet connection. So for the networking issue, I think. Okay. So now it will be okay. Can you hear me? Yeah. Hello. 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 Can you hear me? Hello. 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 Can you hear me? Hello. Hello. Hello.
Yeah.
Hello. Can you? Yeah. So can you hear me? Yeah.
Yeah, now yes. Something
Okay.
wrong
So
with
it's okay.
connection.
Okay, so now it's okay. So now you can see here, we can calculate it. Just we can simply remove the cloud from the satellite images, Sentinel-2 satellite images, and after this we can also calculate it the NDVI and NDVI. So basically, this is the normalized difference vegetation index and normalized difference build-up index. So in this time, I can simply apply the formula. You can see for the NDVI formula is that I simply write the formula near infrared, then subtract with red infrared band divided by near infrared plus by red infrared. Okay, so this is my formula for identify that NDVI. Okay, then I also want to show this NDVI result in here. You can see when I want to open this, I can get this NDVI map. So this is the NDVI map. For the water body, I can get the NDVI result in the negative pixel value. You can see when I click on this, I can get the negative pixel value of the NDVI. Okay, so now it will be working. You can see for the NDVI, I can get the negative. Okay, when I want to click on the any part of this vegetation, I can get the positive NDVI result. You can see I can get the positive result NDVI. Okay, then I also try to calculate it the NDVI. It is the normalized difference vegetation in normalized difference build up index. Okay, so it's identify the build up region on the surface. So this equation is that short wave infrared subtract with near infrared band divided by short wave infrared addition with near infrared band. Okay, and I also want to show this result. You can see NDVI or build up index. So this is the build up index. So mainly build up index, when I want to click on the any building area or build up area, I can get the highly positive value. For the NDVI, I can get the 0.2. Okay, for the water body, I can get the negative result. Okay, as
It's
well as we can
like the same NDVI, but
yeah, like the same
but not.
NDVI.
Yeah.
Yeah. So this is our NDVI map, and just you can see, first of all, I simply select my image, and then I simply apply this image for removing the cloud. So I can get the very clear satellite images in here. I remove the cloud from here. Okay. Then I just apply the equation for NDVI. So near infrared subtract with red infrared divided by near plus red infrared NDVI equation, as well as also put here the NDVI equation. Okay. And then I also try to export this map for NDVI and NDVI. So you can see when I click to it, I can see NDVI. I can use here the year of 2016. So this is the NDVI map for 2016. Okay, NDVI map. Okay, when I want to simply run, so now this map will export it. You can see.
Okay.
As well as same process, suppose I want to need for the NDVI for 2016, just I simply copy the NDVI, simply copy and use here, I paste in here, and also put this is the NDVI. I simply change the name NDVI and click to the run. So now you can see our tax tab is also running, and then I simply click on here and then click to the run. So now it also exported as the NDVI TP images. Then we can easily make this map using the ArcMap software for making the NDVI map as well as also NDVI map in ArcMap software. So this is the process how you can easily get the satellite images and how you can easily get the clear satellite images using the cloud marks band function using the Sentinel-2 satellite imagery. And then you can easily how you can easily calculate this type of equation and get the result for NDVI as well as on the NDVI, and how you can easily download these TP images from here. Okay, so this is the one part. But when you want to work with the another image, suppose Landsat image, okay, so how you can easily remove the cloud for the Landsat. So I simply open my new code editor. Okay, so I also try to show you the process later when I want to work with the land use land cover classification map. Then I use there the Landsat imagery. Okay, Landsat surface reflectance imagery we need to use. So you can see I also try to show you the process, just show the process, and practically I show you the later when I want to discuss about the land use land cover classification class.
Okay.
So you can see I just simply open this image collection. Okay, just see. Simply click on the Landsat. Okay, so here I can get, you can see Landsat 8. I want the Landsat 8. Suppose Landsat 8 surface reflectance. So mainly this image collection we are using for making the land use land cover classification map using the surface reflectance satellite images. And also you can see when I click on here, I can get the surface reflectance. This one band is that QA pixel. You can see QA pixel. So this band is the QA pixel. Okay, mainly this QA pixel, it's also called the cloud marks band. So mainly it, you can see the fill, you can see SRAS, cloud shadow, snow. So also you can see bit 6 has the 2 signal. Also you can see cloud confidence, low, high, medium, cloud shadow confidence, low, high, medium, sono ice, SRAS confidence. Okay, so mainly when I
A
want
lot
to
of
work with
information
this,
about cloud.
yeah, a lot of information you can get. So but when I work with the Google Landsat imagery, then I need to use what the pixel QA or QA pixel. So this band I need to use and then remove the cloud shadow, cloud water or anything without any pixel value, uh, cloud pixel value, cloud shadow pixel value, snow pixel value, we can easily remove from this using this QA pixel band. So I also try to show you this part later when I want to work with the land use land cover classification using
Okay.
these satellite images for the surface reflectance satellite image for making the land use land cover classification using the different types of machine learning such as classification regression trees, support vector machine. We try to complete all of the machine learning method and then try to
Great.
make the land use land cover classification map. Okay.
Okay.
So let's go on next part. In this time, I talk about this part, how you can easily make this land surface temperature monitoring using this satellite imagery and then make the time series chart. Look this time series chart, how you can easily make, and then you can easily observe when the land surface temperature is the high, when the land surface temperature is the low. We can also identify from this time series chart. Okay, so let's go. In this time, I try to show you this part, how you can easily make the land surface temperature monitoring. Okay, so I simply open a new code editor. Write the code in here, no problem. So in this time, I just simply suppose first of all I simply select the region. I want to work for the region, suppose Ukraine. So just I simply import the shape file of the Ukraine. So I think here I already imported the shape file. I want the shape file. Okay, Ukraine cities. So I simply import. simply import this Ukraine cities shapefile in here, and then I simply change the name. Suppose this is the ROI. Okay. And then I simply show the result. I can get the result map dot add layer, and then use here the ROI. And I also need to focus the center of the shapefile. Simply use here the map dot center object, and then use here the ROI and set here the 10 and click to the run. Okay, so now you can see, okay, we can get the all of the cities of the Ukraine. And now I want to make the land surface temperature map for the Ukraine, for the whole country boundary, as well as you can also create this map for any single district. I also try to show the process. So in this time, I want to work with this data and make this map. So let's go.
Okay.
So for this, I can simply go to this data set. I want to work with the MODIS data set first of all. Then I also try to show you that how you can easily make the land surface temperature monitoring using the Landsat imagery. Okay. So basically, MODIS dataset is totally ready-made dataset. We can easily use the dataset and try to make this land surface temperature. You can see this is the Terra land surface temperature global 1 kilometer resolution. Also, you can see another dataset is for 8-day global Terra land surface temperature, 8-day global. We can also use the dataset. Okay, so this is the 8-day resolution, the 1 kilometer. Also, this is the another dataset for land surface temperature. You can see Terra land surface temperature daily. Okay. So mainly when you want to work with this dataset provide you the daily information or daily land surface temperature dataset you can get. And when you want to use this dataset, you can see land surface temperature 8-day. So mainly when you want to work with the 8-day, then you can get the data every 8 days interval. Suppose you can get the data for 1st January, second you can get the second data of 8 January.
Oh, okay.
Then 16 January. This type of time interval which you can get. But when you are using the data set, you can see daily global data set. So we can get the data set daily. Suppose 1st January, 2nd January, 3rd January, 4th January, 5th January. So
Every
daily
day,
data
yeah.
set we can get. Yeah. So in this time, the same process. When you want to work with the daily data set or 8-day data set, the same process. In this time, I want to work with suppose this data set. And you also try to use the dataset for the 8-day. Same process. Okay. So let's go. Try to show. In this time, this dataset you can see time period is that from 2000 to 2022. Between this time period, we can get the dataset. Okay. And this dataset is the global dataset. And you can see this dataset is that we can get the land surface temperature dataset for daily land surface temperature or daily LST dataset we can easily get from here. Okay. So in this time, I want to work with this data set and then try to make the daily time series chart for any specific time period for the daily time series chart. So in this time, I just simply copy. Okay, my networking charge is not. Okay, so in this time, I simply copy this as unique code and then paste in my code editor. I simply take a variable. Suppose this variable name is the MODIS daily. Suppose LST. You can use any variable name and then paste in here. Okay. So now this dataset is imported in this code editor. In this time, I just simply take a date range. Okay. So I simply take a variable, suppose date or start. I simply put the start date. Suppose dot date. Suppose this is my observation time period, start date. I want to observe the time series chart from year of 2000, suppose 2005, 1st January. Okay. This is my start date. And I also want to create a date range function. So mainly date range function is identify when you want to create the date range. Suppose 10 years, 15 years, 20 years, 5 years. So you want to create a range. Okay. So in this time, I take a variable. Suppose this variable name is that date range. And then I simply use the dot date range function. And I can get here the start date and end date.